Welcome to video 12.7e. We're going to rotate another segment in three-dimensional space. Here's example 4. This example is a little bit more challenging, so we'll try our best. Segment AB has endpoints of A, 5, 1, 0, and B, 5, 7, 0. So when we come along the x-axis, that makes it a little bit more challenging. Describe the spatial figure obtained by rotating segment AB about the x-axis, and then again about the y-axis. Again, which axis you rotate about is extremely important. All right, so the first thing we gotta do is graph this. So remember, we start at the origin. I'll just show you this. Don't forget that the x-axis comes out towards you. So once again, these are the x, y, and z coordinates. X, y, and z. So I'll show you here first. So for point A, go 5 units out along the x-axis. Go 1 unit to the right and stop. So over here, here's the origin. 1, 2, 3, 4, 5. From there, go 1 unit out and stop. So that's going to be point A. I like to put that as a reference just so I know how I got there. Otherwise, my brain's got no context what that point means. Point B, go 5 units out along the x-axis. Go 7 units to the right and then stop. 5 units out along the x-axis. 1, 2, 3, 4, 5, 6, 7 units out, and then stop. Notice it's not going to be 7 out here. This x-axis kind of went to the left, so that's why it's going to be off kilter a little bit. So that's point B. And then just to emphasize, I'll make that all be green. So that's my segment. And what I want to do is rotate that about the x-axis. Now it's going to be very difficult to visualize on the board because that x-axis is coming out. It'll be much easier to see here. Okay? So let's say that this is my segment AB. This is my x-axis. I was right about here. All I'm going to do is rotate that segment about the x-axis. So I don't know if you can see, I'm going to obtain a washer. 1 unit away from there, so there's going to be a hole with a radius of 1. Okay? If you don't have that model, what you could do on your paper to better visualize it, you could have this. You could say, oh, I was 5 units out, 1 unit off. I'm like this. And hopefully that'll help you better visualize it. So I'm a washer, and the spacing is going to be 1 unit. So I'll draw a picture of it right here. So that was 1 unit, and that was from there to there, from 1 to 7, that was actually 6 units. From 1 unit to 7 units makes 6 units. All right, so I'm going to say washer. I'll say radius inner equals 1. Radius outer equals 7. Again, I'll just mark it right here. The inner radius is 1. The outer radius is 7, because I'm 1 unit away from the x-axis, and over here I'm 7 units away from the x-axis. I'll show you one more time. So 1 unit away, and then we're 7 units away. Okay, the second part. Rotate AB about the y-axis. So the y-axis is here. This one might be a little bit easier to visualize. So notice I'm 5 units off of the y-axis, and this thing is just rotating around. I'll show you on this model. So again, we were like right here, and all we're doing is rotating about the y-axis. Let's see if I can do it this way for you better. So rotating about the y-axis. Hopefully you can see we're going to obtain the shell of a cylinder, a cylindrical shell. We'll call it a cylinder. So again, if you wanted to draw the reflection, remember we're 5 below, just imagining being 5 up as far as seeing the cylinder happening. So cylinder. The radius of the cylinder is the distance from the y-axis to that segment, and that distance was 5. So the radius is 5. The height of that cylinder is the length of segment AB. AB goes from a y value of 1 to a y value of 7. So again, that's 6 units. So the height is 6. So hopefully we can visualize that. Again, this was the more challenging one. So there you have it. Another example on how to rotate a segment in three-dimensional space and get a cylindrical shell, or as we're going to call it, a cylinder.